Okay, we're still in lesson 3. This should be the last thing that we do. So here we talked about this a little bit yesterday. We ran out of time. We talked about these triangles being similar to each other. We had that big triangle, right? And you've got this little triangle right here. And they are similar to each other because they both have, let's see, I should have put this right here also. They both have right angles, right? Because they're both right triangles. So they have one. Now remember, all you got to do is show 2 angles of one triangle equal 2 angles of another triangle.
Excuse me, teachers, please dismiss 9C, Mrs. Holt's homeroom, to Pusey Center for pictures.
So if I can show 2 angles of one triangle equaling 2 angles of another triangle, then the triangles are similar. If the triangles are similar, then you know the corresponding sides are in proportion, what we talked about yesterday. Okay, so there's one pair of angles that are equal to each other. Where's the other pair? We talked about this yesterday, I believe. It's this one right here. They both share that angle, don't they? The big triangle shares that angle, and the little triangle shares that angle. So there's 2. So they are similar, which means the sides are in proportion. Okay? If you want to, they do this in the book. I'll tell you what. Let's do this real quick. Yeah. Let's do this. Let's make it a little smaller. I don't want to make them quite so, well, I don't know. I'll tell you what. Let's do this. Let's move this out of the way. Oops. Sorry. Guess I should have paused this, shouldn't I? But and oh, come on. Sorry. What can I grab? That right there. Okay, there we go. Alright, let's just push that out of the way a little bit, and then watch. This is the big triangle, right? And I'm going to just keep it in proportion. I'm just going to make it smaller. Let's see if I can get it to fit right here. Alright, there we go. Alright, so there's the 2 triangles right there. Do you agree? You don't have to do this, but at first, the first time we do this, it might be good to see the 2 separate triangles. Okay, so let's put the sides on here. Let's do the small one first. What would this side right here be? This is the hypotenuse. What would that be? That would be A, and then the bottom 6, and then the up and down would be 4. Remember, this is a right triangle, isn't it? What about this one? Let's do the up and down first. What would that be? It'd be C. What would the bottom be? It'd be 10, right? Because it's the whole bottom. It's 6 and 4, which would be 10. This is part that tricks most people up. What would that whole thing be right there? What is it? B? Is it? From here all the way down to the bottom is just B? No, from here to here is B. Would it be AB? What are you telling me when you say AB? You're right, you're saying A times B. Is it A times B? Mark, what is it? It's A, not times B, well, what? A, it's these 2 things together. Jacob, help me out. What would this be? Good, Aubrey, say it. A plus B, right. This would be A plus B, not AB. There's a big difference, isn't there? Okay, if, you know, adding the 2 and multiplying the 2 could be quite different. All right, so here we go. What we want to do is we want to set up some ratios. Let's see what we could do first. Tell you what, look at this little triangle. What could we find on that little triangle without even worrying about that big triangle right there? Find A. That's right. How can you find A? Pythagorean Theorem. Now, is this one of our nice little triangles, 3, 4, 5? Is it?
No.
Nah, because I got a 4 and a 6. This would be a 2, 3. There's no 2, 3 anything triangle, okay, as far as nice whole even numbers. So what we're going to do is we're going to do Pythagorean Theorem and actually solve for this. So let's do it. I've got a squared equals 4 squared. That's supposed to be a squared. That's ugly. Let's try that again. Okay, 4 squared plus what? 6 squared. And so a squared equals 16 plus 36, and that's what? 452? Is that right?
Yep.
If you take the square root, right, because you got to get rid of that squared, so what is it? It's the square root of 52. Let's just keep it the square root of 52.
That way you don't get
Yeah, then you want to get decimals and stuff. So we're just going to keep this the square root of 52. So you come back up here. What's this going to be now?
square root of 52 plus B.
Very good. Okay, it's the square root of 52 plus B. See that? So at least we got a number in there now. All right. Let's see. What do you think we could do here? We could solve for C. How could we solve for C? Remember what's true about these triangles. They're what?
Similar.
They're similar to each other.
4, since 4 is on the small one, that also be 4 for C?
Well, would this be 4? Well, they're the ones that are corresponding to each other. I mean, this is definitely bigger than this. We can't
Yeah.
say it's 4, so it's got to be bigger. But we set up a scale factor. Remember that? What two corresponding sides do you know? Well, I know the 10 and the 6, right? So let's do the scale factor. I'll just write it in here. The scale factor is what? 10 to 6. Or if we reduce that, what is it? 2 goes into that. 5 to what? 3. Okay, you can use 10 to 6 if you wanted to. Sometimes it's just easier to use the smaller reduced number. Okay, so we're going to make it 5 to 3. So let's solve for C. So our scale factor is 5 to 3 equals, now we went from the big one to the small one. So if I want to solve for C, I'm going to go what? C to 4. Good. C to 4. C over 4. And now we can solve for C. You could cross multiply, but since C is already on the top, what could I do? Yeah, just multiply it by 4. Multiply that side by 4 over 1. That cancels. So C is equal to what? 20 over 3. And we'll just keep it like that. So that's another answer. So now we got two answers, don't we? We got A and we have C. Now all we have to do, it's an ugly 3. Alright, that's better. Now all we have to do is solve for this right here. Well, what we can do is this. Since we know our scale factor, alright, which is 5 to 3, we can set up a ratio again. 5 to 3 equals this, square root of 52 plus B, to what? Come on. We're comparing, look, we compared 5 to 3 or 10 to 6. We compared this side to this side. So what is the length of this side? Square root of 52 plus B. What's the length of this side? It's just the square root of 52. Alright, do you see that? Tell you what, just to give me some more room, let's get rid of this stuff right here. We okay with that? Because we've already used it, right? So we're done with that. I just want to give myself some more room. Let's do the scale factor again. 5 to 3 equals, now before we went C to 4, right? So on this one we're going to go this one, which is square root of 52 plus B, to this one, which is just the square root of 52. So let's do that. So it's the square root of 52 plus B over what? Square root of 52. And now we have to solve for B. Now our math is a little bit more involved on this problem, but it's the same idea. It's the same kind of thing. We're going to cross multiply. Now a lot of people look at this and say, oh, the square root of 52's cancel out. But do they? No, not when this is being added. If this is being multiplied, then they would cancel out. But they don't here because it's being added. So don't just cancel out the square root of 52. Okay? So let's cross multiply now. I'm going to do this one first. So it's 3 times square root of 52 plus B equals 5 times the square root of 52. You with me? Let's do what to this 3? Distribute. Good. Multiply it, right? Distribute. Same thing. So it's 3 square root of 52 plus what? 3b. Good. Don't forget that 3 equals 5 square root of 52. Now watch why it's so nice to keep it square root, because look what I can do. How can I get rid of that 3 square? That's right. Subtract it from both sides. So if I subtract a 3 square root of 52, that's right. So I've got 3b equals 2 square root of 52. Exactly. Divide both sides by 3, and that's what b is. I'll just write it all by itself here. 2 square root of 52 over 3. And you can keep your answer just like that if you want.
If you were to do that when you get a decimal also.
Yeah, you throw that in a calculator. You can get a decimal, and if you want to, you can. All right, you can chuck that in a calculator, get a decimal approximation. You could have chucked square root of 52 in a calculator, got a decimal. You could put 20 over 3 in a calculator, get a decimal. But don't you think it's a lot easier just keeping it like that? Yeah. So that's what A is equal to. There's B, and there's C. I would just leave it like that. And in fact, when you look in the back, if you have odd problems in the back, odd answers in the back, then they'll probably keep it like this, is my guess. If you look at the example, yeah. Oh, you know what they did? They simplified the square root of 52. I'll just show you. I'll let you leave it like this for now. As we work on simplifying square roots in the in the future I may have you simplify that. But square root of 52 actually simplifies. And I don't think that's one of our lessons, but let's do this. Remember how to do any of these? What goes into 52? 2 does, right? It's an even number. So 2 times what? Can you do that in your head? 26. Good. Because 50, 2 goes into 50 how many times? 25 times. 2 more is 26 times. You get that? So it's 26. So it's 2 times 26. Well, let's break down 26 a little bit further. What times? 13 times what? 2, right? Would you agree with that? That's all under a square root. Look, 2 times 2 is 4. What's the square root of 4? Because it's under a square root, isn't it? So it's just a 2. And then can you simplify the square root of 13? No. So it's 2 square root of 13. So if you look in the book at the example for A, they write it 2 square root of 13, don't they? That's the simplified answer. I'd be okay if you just kept it the square root of 52. I'm not going to be that picky right now on that kind of stuff. Maybe eventually I will, but right now I'm not. Okay? But you could write it 2 square root of 13. It's the same exact thing as that. You could also throw it into a calculator and get a decimal if you wanted to. But this book really doesn't do that a whole lot. Okay? For the most part, they keep it inside the square root. Sometimes that makes it a lot easier. I'd say a lot of times that makes it a lot easier for you just to keep it as a square root. Okay? Does that make any sense at all? Alright. Wow, looks like a big old mess here. But you followed along, didn't you? And if you didn't, if you missed some things, go on YouTube, look for it, okay, and use it. You know, because we're wasting all this stuff if you don't actually go and use it. Alright, just because it's up there, it's not going to help you unless you go to it. Alright, let's stop this and let's go to another type of problem.